video, we're going to be covering Entity Relationship Diagrams, or ERDs. We're going to be exploring what they are, how to read them, and how to make your own. You might be asking, what's an ERD? Well, it's sort of like a blueprint for a database. Just like when you're building a house or a building, you don't just start hitting together some nails and wood. You hire an architect, and you come up with a plan, a blueprint, before you start building. Same idea for databases. We need to make a blueprint for our database that covers the model of our database before we start implementing it. So ERDs are a diagram format that allow us to make that blueprint and sort of plan everything out before we start coding or putting any data structures together. So before we begin, there are a few required readings, and this would be Chapter 5, Database and Content Management from your textbook, as well as Knowledge Extension 6, Database Design from the same text. In addition to this, there's also some ERD tutorial slides that you might want to check out either after this video or before watching it, and those would be on the OWL course site. So let's get into it. So you might remember this example from the database lectures. So this is a database that might be used by a professor to track their students, their grades, as well as emails they've sent them, and office hours visits they've had. So one problem we might have is while we're developing this, or maybe while we want to share the structure of this with someone else, how could we share that information with them? How could we describe this database's structure? So we could just give them the database itself, maybe the access file. Well, that has a few problems. It's going to include a ton of data that might be confidential. We don't really want to send them the data. We just want to describe what kind of data this database stores. Or we might call that the metadata. That's data that describes other data. This is also an important thing when we're actually developing the database. When we haven't actually created it yet, so there's no database to share, we might be working in a team, and we want to be working on deciding, making decisions on what this should store, and we're going to need a way to communicate that back between the different team members. So by structure, or metadata, or data model, what I'm talking about is what data is going to be stored in each table. So for example, we have an email table, and we know that that email table is going to store an email number. That's sort of the primary key for this table. It's going to store a date when the email was sent. It's going to store the message, the content of the email, and the student number representing what student sent it. And that sort of creates a link or a relationship to this table, the student table, which stores information about the student number, student name, homework, assignments, midterms, things like that. So how do we describe these sort of like relationships between these tables and these sort of fields or columns that are describing what's going to be stored in the data? So one approach we could take would be using a text-based format. So this format is shown a little bit in your e-textbook. And what it does is it describes each table in the database as one line of text. And you can see here, well, let's type it, that the table names are in all capitals at the start of each line. And then inside that, inside these brackets here, we have all of the fields that this table will have. Then we have a few special notations for things like primary key by underlining them, and italics, might be a little bit hard to see here, but student numbers in italics, for foreign keys. So that's an okay way of representing them, but it does have some limitations. First, it lacks relationships. We don't really know how email and student, these tables, are related, and we don't really know how student and office visit are related. It also lacks properties of these attributes. So for example, for date in the email table, we don't know if date is optional or not. Are you allowed to have emails in your email table that don't have a date? Or do all of them have to have a date? If we look back, click, you'll notice that things like homework 1 here are missing values in some cases. So presumably that's allowed for homework 1, but just from this text-based description, it'd be hard to discern that. So we need something that's a little bit more descriptive. The other problem is this is really hard to visualize. You might have a database with like 10, 20 tables, maybe even more. It's going to be hard to just see a text file with all these lines and sort of get an idea in your head about what this database is going to look like and what it's going to store just from reading the text. So maybe there is a better way. And one such method would be using a diagram. What we're seeing here is something called an entity relationship diagram. And before I go into too much depth in describing that, there is some definitions that we need to explore. So I'm going to go back a few slides. So in this example, we talked about databases. We talked about different tables. Each one of these boxes here is a different table. We have the email table, we have the student table, and we have the office visit table. When we're talking about a data model behind a database, in terms of entity relationship diagrams, instead of tables, we call these entities. So this would be the email entity, this would be the student entity, this would be the office visit entity. Instead of fields or columns, when we're talking about the data model, we would describe these as attributes. So date would be an attribute of an email. Student name would be an attribute of a student. Notes would be an attribute of an office visit. And between them, we would call relationships. So we can see that we have a student number here in the email table. This is a foreign key. This would be forming a relationship between the email table and the student table. So instead of tables, when we're talking about data model, we say entities, and instead of fields, we would say attributes. Now that we have that out of the way, we can talk a little bit more about entity relationship diagrams. So what is an entity relationship diagram, or an ERD? It's a type of flowchart that illustrates the database's data model. So that's sort of the metadata or the structure behind the database. We often use this as part of the development of the database before we've even created the database. So the process usually goes is we ask the users, the people who are actually going to be using the applications that use this data, what sort of data they need to store. And this is called requirements gathering. We need to know what our application needs to do, what sort of data is going to need to be stored by this database. So the actual process of requirements gathering is a little bit outside the scope of this course. It falls more into software engineering. But for our purposes, we're going to assume that we've required the requirements from the users. And now we're on the step of going from those requirements, so the list of things the users say they need, and developing that into a data model that's going to describe what our database is going to store. For example, is it going to store emails, is it going to store students, and what the attributes of each one of those things, each one of those entities, is going to be that it stores. So ER diagrams show both the entities, the attributes they contain, and as well as how they are related to each other. So the end goal of all of this is to sort of create a blueprint or a plan of how we're going to create the database, and then that gives us our sort of design for when we actually start implementing the database. So you might think that's not super useful. Why don't I just jump right to creating the database? And for very easy examples or very easy cases, you probably could just jump right from requirements right into creating the database. But when we start getting into more real life scenarios where we might have complex databases with hundreds of tables, hundreds of relationships, hundreds of attributes, we do need to have some planning. Otherwise, it can lead to quite a big disaster if you just jump right into it. We also lead to problems when we're working with a team. Often in big companies and big complex systems, it's not just going to be you developing the database. So you need to be able to communicate these requirements in the form of a data model to the other staff or other developers that are working on this database. So now I'm going to go give you sort of a quick crash course in the different notations and symbols used in entity relationship diagrams. So once again, it is important to note that this video is just a summary. You do need to read that How to Create an ER Diagram, your ERD document on OWL for full details. And that's a really good set of slides. It's going to take you through the steps. I'll give each one step you have to take to go from requirement to actually creating the different entities, different relationships, different attributes in the entity relationship diagram. So I highly recommend that you read that. You really won't be getting a complete picture of ERDs without reading that document. So in terms of ERDs, that's basically your assigned reading, because the textbook doesn't go into as much depth as we'd like for ERDs. After you've read that document and watched this video, there is going to be some tutorial videos that will then show you some examples so you can sort of follow along and apply that knowledge. So you're not completely on your own. And then we'll have consulting hours in the forums where we can answer any questions. So for now, I'm just going to sort of give a quick overview of the notations used in these diagrams. If you're a bit confused, don't worry. I believe that document that I referenced right there will clarified a lot, and we also have some examples that we'll go through in the future videos. So the first thing, and is what these diagrams are named after, are the entities. So remember, these are eventually going to become the tables in our database. And in our diagram, you can see here that we draw them as different rectangles. So each rectangle in our diagram, or these little boxes, highlighted in green right now, are the different entities. So we have an email entity, we have a student entity, and we have an office visit entity. You can see that each one of them has their name at the top, and it's separated from the information that comes below it with this dark bar. And the other thing you'll notice is all these names are in all capitals. They're fully capitalized. So that's important because it makes it really easy for us to tell what's an entity, what's an attribute, what's a relationship when we actually implement this in the database. And we do expect you in your assignments to follow this same capitalization scheme. So the next thing these diagrams store are the attributes. So that's sort of the information each table is storing. Eventually, when we implement these into a database, these will become the fields or the columns in the database. And these are all denoted by lines of text inside of the boxes, inside the entities. So each one of these inside these boxes here are going to be a different attribute of the entity. So for student, we have student number, we have student name, we have homework 1, homework 2, and midterm. And you'll notice with the capitalization here is that the beginning of each word is capitalized. We are allowed to have spaces, but that might not always be the best idea depending on the database management system you're using. We'll talk about that a little bit more when we actually get to implementing databases. Once again, these attributes will become the fields in our database, and they describe the sort of properties or attributes of each one of the tables, each one of the entities. So the next thing these denote are what are the primary keys. If you recall from the database lectures and your database readings, primary keys are an attribute or a field that uniquely identifies that entity, so that instance of the entity. So for example, student number in the student table that we can see up here uniquely identifies each student. Each student has their own student number, and it's guaranteed to be unique. So if we were searching for a student, we could do that by student number, and we would be guaranteed to find the correct student. If, for example, we did it by student name, or maybe what grades they had, we'd have issues where we could have conflicting names. We could have overlaps. Like it might be rare, but we could have two students with the same name, we have two students with the same grade, things like that. So our tables usually need to have a primary key that is guaranteed to be unique. It's guaranteed that there'll be no students, for example, with the same student number, no emails that have the same email number, and they'll be guaranteed that there'll be no visit IDs in our office visit table that have the same visit ID. So it is important that those are unique. So each instance of that entity has to have a different value for the primary key. When we start getting into queries and actually using these databases, we'll see that how we can use these primary keys to easily look up things and sort of relate the different tables. For now, we just need to know that primary key means it's a unique value. There can only be one value for each instance of that entity, and each entity needs that unique primary key. And the way we denote that, if it isn't obvious yet, is it's an underline. So the primary keys are underlined in the ER diagrams. So the next thing are the attribute properties. If you recall from a few minutes ago, I said that that text-based description lacked sort of a description of the attributes, or properties of the attributes. For example, we didn't know if something was optional or not. So it's a bit hard to see, but these little bullets here, and going down the side, there's each attribute has a bullet beside it, give us a little bit more information about those attributes. They tell us the properties of the attributes. So they would, for example, define if it's a primary key, if it's unique, if it's required, or if it's not required. So in the type of ERDs we're going to be seeing, created with the DIA editor, there's 3 different bullets that we're going to be seeing. There's the primary key attribute bullet or symbol, which looks like a diamond. And that's just another way of denoting that this attribute is a primary key. So there's 2 ways, both the diamond and the underline. The next one is a completely filled circle, like we have right here. And that means it's a required attribute. So it means every instance of that entity in your database, sort of every row in your database for that table, has to have a value for that field. So if we look back, we can see student name has a solid bullet right here. So that means every student in our database has to have a name. That can't be left out. Similarly for email and for office visit, dates have a solid bullet beside them. So that means that date is required. We can't have a instance or a row in our database that has a date with no value given. And the last one is an empty circle. And that means this attribute is nullifiable or not required. So that means it's sort of optional. So if we look back, this would mean, for example, like homework 1, homework 2, and midterm are all listed as being optional because they have these empty circles. So this means we could have an instance of a student that has no grade for homework 1, homework 2, and midterm. It's optional that we include data. They could just be left blank or left as null. Also notice that we have notes down here in the office visit, which also has that empty circle. So that means some of the office visits could just have no notes. There could be nothing there. So this is an important thing to note when we're creating the database, because when we actually get to implementing it, there'll be certain properties you have to set for each attribute. They'll sort of act as sort of constraints and keep the consistency of the database maintained. When we start bringing this into a real-life system, we don't want to get cases where we have data that's incomplete all over the place. We want a level of consistency in our database, in our data, and setting these properties correctly and thinking about them before we even implement the database in our data model will help a lot with that. It's important when we're thinking about attributes, we need to think of three things. Is it a primary key? Is it required? Or is it not required, nullifiable, optional? The three things. Is it a primary key? Is it required? Or is it not required? So the next big thing that the ERD holds, and this is probably the most complex thing, but also the most important thing, are the relationships between these different entities. So you can see up here that we have a relationship between email and student, and we have a relationship between student and office visit. What these define are how these are connected. So this relationship here that we call emailed, as denoted by just a name above the line, states that the student sent this email. Visited is going to say that the student visited this office hour. So it allows us to make sort of connections between these different entities. And we define these using a line, but we also notice that there's some interesting symbols here. You can see we have these shapes here and shapes here. And this is what we call crow's foot notation. And it's the notation we're going to be using in this course. Some ERDs use a slightly different notation, but everything in this course is going to be targeted towards this crow's foot notation. And this is going to tell us about the cardinality and the participation of this relationship. And don't worry, we'll get into that in a second. The other thing to note are these relationship names. They're in all lowercase, so there's no capitalizations. This capitalization scheme, or this capitalization notation that we've been seeing, allows us to quickly identify if something's an entity, if something's an attribute, or if it's a relationship, because entities are in all caps, attributes have the first letter capitalized, and relationships have no capitals at all. So it's important that you maintain this in your ERDs and your database for this course, just because we want to have this consistent notation to make it very easy to understand. So now we're going to talk a little bit about the cardinality and the participation defined in these relationships. So cardinality indicates the number of instances of the entities that are involved in the relationship. So it's important to note that this doesn't mean the number of entities or the number of records inside your database. Rather, this defines how many entities are involved in a single relationship. So that might sound a little bit complicated, but let's take a little example here. So this is our example from the database lecture, and we have our email table here, and each email is assigned to a single student. And in the student table, we can see that each student has a unique student number. This relationship between student and email is what we would call one-to-many, or 1:n. And what this means is that within this relationship, there is going to be one student that can send many emails. So one student could have sent 0 emails, they could have sent 1,000 emails. It could be anywhere between 0 and basically infinity. And that's in the direction from student to email. When we look at the other direction, we'll see that for every email has to have exactly one and only one student, because you can't really have an email sent by multiple people. So the same sort of thing when we're looking at the relationship between student table and office visit. Again, it's going to be a one-to-many relationship, because a student could visit the professor's office hours 0 to like an unlimited number of times, theoretically. So that means that each office visit has to be assigned to exactly one student, but a student could have multiple office visits. So by this n, we mean many, sort of like some number, and by the 1, we mean 1 and exactly 1. So one-to-one relationships would be a single entity to a single secondary entity. So that means there can only be one on both sides. The one-to-n, or one-to-many, means that there's one side, there's just one, and the other side, there could be many. That's sort of like what we saw here, where we could have one student always sending an email, but that student could send multiple emails. And we could have many-to-many relationships, which are a bit more complex, where you could have many on both sides. So this might sound a little bit complex right now, but once again, those slides that I mentioned before are going to go into this in far more depth and give you examples for each case. The second thing we talked about is participation. It's also called modularity or multiplicity. So participation of an entity in a relationship indicates whether all or some of the instances of the entity are allowed in the relationship. So this sort of tells you if their participation in that relationship is optional or mandatory. So by mandatory, we mean that all instances are involved in the relationship, or by optional, we mean that not all instances are involved in the relationship. So every time an instance is added to an entity, must an associated instance be added to the related entity. So again, that sounds a little bit complicated, so let's take a look at an example here. When looking at this email and student example again, specifically the relationship between the student table and the email table, we can see that the student is optional in the sense that it doesn't have to participate in this relationship, whereas the email is mandatory. Why? Well, a student is not required to have an email. We could have many students in our database that never send an email to the course professor. But if we look at it the other way, from the email perspective, every email has to be part of this relationship. It's mandatory that it's part of this relationship with the student table, because every email has to have a sender. And in this case, we're assuming the sender is always a student. By participation, we're talking about, is it mandatory or optional that they're part of the relationship? We can also take a look at the relationship between the student table and the office visit table. In the same way, we would say student is optional. The participation of student in this relationship is optional because some students may never book an office hour and may never attend an office hour. Whereas on the office visit side of things, it is mandatory in this relationship because every office hour has to be with the student. So that's great that we now know what participation cardinality is, but how do we denote them in an ERD? So once again, we're going to do that with crow's foot notation. There are a few different notation styles, but the one we're going to be focusing on in this course is crow's foot notation. And that uses a few different symbols on those lines that denote relationships between the entities. So for cardinality, we have two options. We have one or many. One is defined by a straight line, kind of looks like a 1 on the line, and many looks like a greater than sign. So a great way to remember this is you think of the 1 as a 1, like the number 1, and you can think of the many as a greater than sign, sort of a large amount. When we talk about participation, that's denoted by two symbols as well, and we can either have optional participation or mandatory participation. And optional is defined with a 0 or a circle, and mandatory is defined with a line. You can think of that as a 1. So a great way to remember that is optional is 0, sort of like a circle, and mandatory you can think of as a 1. So when we put these together, you'll get two symbols on each side of the line. So for example, this means 1 and only 1, 2 lines. This would be 0 or 1, This would be one or many, and this would be zero or many. So let's take a look at this ERD for that example and sort of break down these different ones. So for cardinality, I'm going to highlight all the cardinalities, and they're always the one that's closest to the entity. And there is a bit of a trick here. So you might be inclined to think, well, the cardinality here is many, so that must be email. But that's not how we read an ERD. We read it going this way. It's kind of a big arrow. But the way it works is we read email, and we look over here, and then we see the cardinality here. So we could say that email's cardinality is 1, while student's cardinality is many. So what does that mean? So that means that in this relationship, email always has one student, while a student can have many emails. If we look down here, we're going this way from student to office visit. We read the cardinality here, and we see it's many. So a student can have many office visits. When we want to read it the other way for office visit, we go up, and we see the cardinality here is a 1. So that means that office visits always have one student. So now let's take a look at the participation. And remember, that's that second symbol, the innermost symbol on these relationships. And just like with cardinality, we have to read it going from one entity to the other. So if we want to know the participation of email, the email entity in this emailed relationship, we take a look from email to student, and this would be the participation right here for the email entity. It's a 1 or a dash, so that means email has mandatory participation in this relationship. If we want to know the student's participation, we go the other way. We see this symbol here, and we say that the student's participation is optional. You can think O for optional or 0. You can also sort of think of this as the minimum. So for email, there always has to be a student associated with it. And for student, they could have 0 emails. When you take it as a whole, you could say that the student has 0 or many emails, and each email has 1 and exactly 1 student. Then we can take a look going down to office visit as well. We go from student down to office visit, and we see that we have a O or a 0 symbol here, a circle. And what that says is that this participation is optional. Where we go up, we see that there's a dash, so that means participation of office visit is mandatory. So what this means is a student can have 0 or many, 0 or more office visits, whereas each office visit has to be associated with 1 and exactly 1 student. So one of the pitfalls students often fall in is figuring out which side each of these are on. So you have to remember that when you're sort of going this way from email to student, this describes how student and email are going to be connected. And going the other way, we look at this side. So when we're looking at student, we know that student has to have many or 0 emails. And we're looking down from student to office visit. We look over here and we see that student has 0 to many office visits. When we're going the other way from email to student, we'd see 1, 1. So that means every email has to have exactly 1 and only 1 student associated with it. And same thing going up from office visit. So the confusion in there usually often comes with we're not looking at the one that's touching it to see how it's part of participates or has cardinality in this relationship. We're actually looking at the symbols that are closer to the other side of the relationship. It can be a bit tricky to get down, but with practice it becomes a little bit more clear. So that's all I really have for you in this video, but there are some more things to cover after it. So where do you go from here? Well, hopefully you've already read the slides, how to create an ER diagram, ERD, but if you haven't, those are on OWL, so make sure you check them out. Then watch the ERD tutorial. This is going to have an example of creating an ERD from scratch based on some requirements for a fictional doctor's office. After that, watch the DIA tutorial, and this will tell you how to actually create these diagrams in the DIA diagram editor. So far, we've only been doing them on paper or just showing pictures of them on the computer. That one will tell you how to actually make them with DIA. So after you've watched those videos, the next step is going to be to check out the ERD homework posted on OWL. That's not my lab homework. It's actually a little activity that you can do on the OWL site. where you sort of build up your own ERD from some requirements, or you answer some questions about an ERD. And then once again, if you have any questions, feel free to post on the course forums, send me an email, or attend one of our TA's consulting hours. So go get some paper and a pencil and start in on those tutorial videos. Thank you for watching, and have a great day.